Hi everybody. Well, it's time to discuss questions on probability. Let's begin with the first one. The first question says that two players are there, Sangeeta and Reshma, and only they both are playing a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning the same match? Now see, if there is one match being played by two people, either of them can win, right? If Sangeeta is winning in that match, then Reshma will have to lose in that match. Or if Reshma is winning in a match, then Sangeeta will have to lose in that match. So if I want to find out probability of Reshma winning the match, let me say if A is the event, Reshma wins the match, then can't I say that this is the same event when Sangeeta loses the match? Right? Sangeeta loses the match. Until and unless Sangeeta loses that match, Reshma cannot win the match, and if Reshma wishes to win the match, Sangeeta will have to lose the match. So either I can describe the event as Reshma is winning that match, or I can say Sangeeta loses that match. And B is the event that Sangeeta wins the match. Sangeeta wins the match. Now please try to understand the situation. Sangeeta is winning the match is event B. So negation of Sangeeta winning the match would be B bar. What is negation of event B? Sangeeta wins the match. What is the negation? Sangeeta does not win the match. So Sangeeta loses the match is actually B bar. So B bar is what is same as A. If I want to find out the probability of Reshma winning the match, that means I want to find out probability of A, but actually A is nothing but B bar, because Reshma winning the match is same as Sangeeta losing the match. That means Sangeeta not winning the match, which is the negation of event B, that is Sangeeta winning the match. So this is negation of event B. I need to find this out. What is probability of negation of an event? It is 1 minus probability of that event. Because probability of an event plus probability of negation of that event is 1. So it is 1 minus probability of Sangeeta winning the match. Sangeeta winning the match. This is equal to 1 minus 0.62, because it is already given to you that Sangeeta wins the match has probability 0.62. This happens to be 0.38. So the probability of Reshma winning the match or Sangeeta losing the match, anything, is 0.38. Let's focus on the next question. It says that which of the following cannot be the probability of an event? Now if you can recall the concept of probability, it is not just a real number, but actually probability of any event you take is obviously always greater than equal to 0 and less than equal to 1. It is a real number packed between 0 and 1. Minimum it can take the value 0, maximum it can take the value 1. Here if you see, 2 by 3 is packed between 0 and 1, so this can be the probability of some event. Minus 1.5 is less than 0, right? And probability is always greater than or at the min equal to 0. It cannot be minimum to that or lesser than that. So negative numbers, negative real numbers can never ever be probability of any event, and numbers beyond 1 can also never be probability of any event. 15% can be written as 15 upon 100, which is 3 upon 20, which is 0 point something, which is again greater than 0, less than 1. So this can be the probability. And 0 point something, which is again between 0 and 1, even this can be the probability. So it is this which can not be the probability of any event, because probability of any event is always between 0 and 1. Next question says that Savita and Hamida are friends. What is the probability that both are going to have different birthdays, and what is the probability that they have the same birthday ignoring a leap year? So right now we have to take that the year in which they are talking about the celebration of birthdays is not a leap year, it consists of 365 days, right? If I have 365 days and I am talking about birthdays of these two girls, it can arrive on any day. So what are my total possibilities of birthday coming up? It can be on any of these 365 days. So total elementary events associated with this experiment total elementary events associated with this experiment is 365. Any of the days of 365, out of these 365, can these two girls have their birthdays? So in total I have 365 days. Now first thing, what is the probability that they will have birthdays on different days? So let me fix this. Let Hamida celebrate her birthday on some day out of these 365 days. Then how many days are there as possible days for Savita to have her birthday if it is sure that both of them should have birthday on different days? Savita and Hamida are friends. In these 365 days, you take one day in which Hamida is celebrating her birthday. Now that day crosses out for Savita to have her birthday on that day, right? Because both of them cannot have birthday on the same day for the first condition. That means out of 365, one possibility has gone for Savita to have her birthday, and it is that day in which Hamida is celebrating her birthday. So favorable number of days left for Savita to have her birthday are 365 minus 1, which is 364. So for Hamida and Savita to have birthdays on different days, what is it? Number of favorable days are what? 365 minus 1, which is 364. So you can just take any one of them having their birthday on some day, let it be any day. Now for the other person to have her birthday different from this person's birthday, only 364 possible days are left. So number of favorable outcomes are 364 and total number of outcomes are 365. Therefore, probability of Savita and Hamida celebrating birthdays on different days is 364 upon 365. Clear? Number of favorable outcomes upon total number of outcomes, or number of favorable elementary events upon total number of elementary events. Next says, what is the probability that they celebrate birthday on the exact same day? Now if suppose A's birthday on same day, then what would be negation of A? Birthday on different days, right? I have already evaluated the probability of them celebrating their birthday on different days. That means I already have evaluated probability of A bar. What is it? 364 upon 365. I want probability of A. What is the probability that they celebrate their birthday on the same day? Probability of A plus probability of A bar I know is 1. So probability of A will be equal to 1 minus probability of A bar, which is 1 minus 364 upon 365. This gives you 1 by 365 as the required probability. Moving to the next question, it says that Harpreet tosses two different coins simultaneously. One is of rupee 1 and another is of rupee 2. These are two fair coins which Harpreet is tossing. What is the probability that she gets at least one head? Now when two coins are tossed, you either get head on the first coin, head on the second, head on the first, tail on the second, tail on the first, head on the second, and tail on the first, tail on the second. There are 4 possible outcomes or 4 elementary events associated with this random experiment of tossing two coins. You want to know the probability of the event which is getting at least one head. Okay? Now how many elementary events do you think are in favor of this event? If you look at this, here there are two heads, that means there is at least one head. There is exactly one head, that means there is at least one head. There is exactly one head, there is at least one head. There is no head, there is not even one head here when both of them have tails. So out of these four, only 3 elementary events are in favor of event A. So I will say A is at least one head to which HH, HT, TH are favorable. Therefore, number of elementary events favorable to event A are 3 and total number of elementary events are 4. So probability of A is 3 by 4. Clear? Let's move to the next question. It says that a box contains 90 discs which are numbered from 1 to 90. So there are 90 discs in a box. Each disc is represented by a number from 1 to 90, from 1 to 90. So each disc you pick up, it is going to have some number from 1 to 90. One disc is drawn at random. One disc is drawn at random. So your experiment is what? That you are withdrawing a disc from a box of 90 discs numbered from 1 to 90. What is the probability that it bears a 2-digit number? What is the probability that the number is a perfect square? What is the probability that the number of the disc that you have withdrawn is divisible by 5? Now if this experiment is of withdrawing a disc from a box of 90 discs numbered from 1 to 20, then how many possible outcomes are there? Any disc from 1 to 90 can be withdrawn. So there are 90 possible outcomes, right? So number of elementary events is what? Total number of elementary events associated with this experiment of withdrawing a disc from the box numbered from 1 to 90 is 90. Any disc can be withdrawn and there are 90 discs numbered from 1 to 90, right? Now I am saying event A is that disc withdrawn has a 2-digit number, right? Now out of these 90 discs which are numbered from 1 to 90, how many do you think, that means I can withdraw the first disc numbered as 1, I can withdraw the second disc numbered as 2, I can withdraw the third disc numbered as 3 and so on till withdraw the 90th disc numbered as 90. How many do you think of these outcomes, the discs which can be withdrawn, are in favor of this event? Are in favor of this event. You know that if I want to withdraw a disc which should be numbered as a 2-digit number, then it should not be a disc with number 1, with number 2, 3, 4, 5, 6, 7, 8, 9. That means it can be a disc numbered as 10, 11, 12, 13, 14, 15, 16 and so on till 90, but it should not be from 1 to 9. So out of all these 90 discs, the first 9 discs are not in favor of this event. Rest 81 discs are in favor of this event. Fine. So I have M is 81, N is 90. So probability of A is 81 upon 90. Out of these 90 outcomes, that is the 90 discs, 90 possible outcomes that can be there, of these 90 discs numbered from 1 to 90, only 81 discs are such in the box which have their numbers as a 2-digit number. So only they are the favorable outcomes to this event. Okay? Next, let's see a perfect square number. Disc withdrawn has a perfect square number. Out of these 90 discs which are numbered from 1 to 90, how many discs have their numbers as a perfect square number? The disc with number 1 is a perfect square, 1 square is 1, 1 square is 1. Then 2 is not a perfect square, 3 is not, 4 is a perfect square, 2 square is 4, 5 is not, 6 is not, 7 is not, 8 is not, 9 is there, perfect square. Then what do you have after this? 16 is a perfect square. Then 25 is a perfect square. Then 36 is a perfect square. Then 49 is a perfect square. then 64 is a perfect square, then 81 is a perfect square, that is it. After this 100 is a perfect square, but I don't have any disk inside the box which is numbered as 100. Maximum there is a box numbered as 81. So out of boxes numbered from 1 to 90, only these many are the boxes whose numbers, or these many are the disks whose numbers are a perfect square. So how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. So your M over here is 9. Out of all the disks numbered from 1 to 90, only these 9 disks have numbers which are perfect square. So them being withdrawn are the outcomes which are favorable to event B. And N is already 90. So your probability is 9 by 90. Next, I have another event, event C. It is getting a number divisible by 5. So number is divisible by 5. That means the disk that you are withdrawing is having a number divisible by 5. If the disk withdrawn is having a number 5, then yes, it is divisible by 5, or it should have number 10, then it will be divisible by 5, or it should have the number 15 on it, or 20, or 25, or 30, or 35, or 40, or 45, or 50, or 55, or 60, or 65, or 70, or 75, or 80, or 85, or 90, and stop. Because disks at the max have only numbers till 90. So it is disks with these numbers which are favorable to event C because they have numbers which are divisible by 5. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So here your M is 18 and N is 90. Therefore, probability of event C is 18 upon 90. Is it clear? Let's now talk about the next question. A lot consists of 144 ball pens, of which 20 are defective and the others are good. Noori will buy a pen if it is good, but will not buy it if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it? Now see, if I talk about event A, that she buys the pen, but it is given to me that she is going to buy the pen only if it is good. That means when the pen is good. So A is the event that she buys the pen, but it is the same event that the pen drawn is good. It is the same thing because only when the pen is good will she buy the pen, and if she is buying the pen, that means the pen has to be good. So this is the same event that the pen drawn is good. Now, how many pens are there? 144 ball pens are there in that lot. When I am drawing a pen, there are 144 possible outcomes of this experiment of withdrawing a pen from the lot of 144 pens. So total number of elementary events in this case, total number of possible outcomes are 144. Any pen can be withdrawn, right? So I have total number of elementary events associated with this random experiment of drawing a ball from this lot of 144 pens is 144, right? Now, out of these 144 pens, 20 are defective and others are good. How many pens are actually favoring the happening of event A? Out of 144 outcomes, if I remove 20, I am left with 124 outcomes. They are the outcomes which are favorable to event A because 20 are defective, rest are good. That means out of 144, 124 are good, 20 are defective. So 124 pens are actually in favor of event A, right? So over here, M is 144 minus 20. You remove the defective ones and you are left with 124 good pens. And you are saying pen drawn is good. So good pens are only 124 in the lot. So 124 are favorable events to elementary events to event A. So you will have N already is 144. So probability of A is 124 upon 144. Next it is saying that she will not buy it. Now if A is that she is buying the pen, not buying the pen will be A bar. that she doesn't buy the pen. That she doesn't buy the pen. What is probability of A bar? 1 minus probability of A. Very easily 1 minus 124 by 144. This will be the probability. When you remove this, what do you get? 20 upon 144, which directly also you could have evaluated, because she not buying the pen is same as that the pen is defective. Only then will she not buy. And out of 144 pens, only 20 pens are defective. So 20 is the number of outcomes favorable to event A bar. That means she is not buying the pen or the pens are defective. Total number of elementary events is 144. So 20 upon 144 would have been the answer in that case as well. Fine. Or you can directly use the formula that probability of A plus probability of A bar is 1. So probability of A bar is 1 minus probability of A. This also to calculate your answer. Next question says, there are 40 students in class 10th of a school, of which 25 are girls and 15 are boys. So there are 25 girls and 15 boys in a class of 40 students. The class teacher has to select one student as a class representative. She writes the name of each and every student on a separate card, the cards being identical. So there is no biasness in any card which is chosen to write the name. Each card looks the same. Then she puts cards in a bag. So how many cards would be there? How many cards would be there? In each card there is a name of a single student written, and there are 40 students, so there are 40 cards which have been put in a bag, and she stirs the bag thoroughly. Then she draws exactly one card from the bag. So there is a bag consisting of 40 cards. Out of those 40 cards, 25 cards have names of girls written on it, and rest 15 cards have names of different boys written on it. This is how 40 cards are there inside that box, inside that bag. One card is being withdrawn. So drawing a card from this lot of 40 distinct cards is what is my experiment. Out of those 40 cards, any card can be withdrawn. All cards are identical. There is no biasness, no fraud in withdrawing any particular card. So any card can be withdrawn. So number of possible outcomes are 40. So with this experiment, total number of elementary events is 40, right? Now what is the probability that the name written on the card is of the girl and is of the boy? Out of these 40 cards, 25 cards have the name of girls written on it, and 15 cards have the name of boys written on it. So if total number of outcomes, possible outcomes are 40, if I say my event A is card has name of girl on it, then how many outcomes are favorable to this event? 25 outcomes, because 25 cards have name of girls written on it. So out of these 40 outcomes, 25 outcomes are in favor of this event. So I have M over here is 25, N is 40. So probability of A is 25 upon 40. Now if I am saying B is card has name of a boy, if the card is going to have name of a boy, that means card is not going to have name of the girl. So card does not have name of the girl. Card has name of the girl, card does not have name of the girl, that means this is A bar. If I have to find out probability of B, that means I have to find out probability of A bar, which is 1 minus probability of A. Probability of A is 25 upon 40, which is 5 upon 8. This is 1 minus 5 upon 8, which is 3 upon 8. Directly also you could have done card has name of boy upon it. So out of 40 cards, 15 cards have name of boys. So 15 outcomes are favorable to event B. So 15 upon 40 would have been the probability, which is again 3 upon 8 if you further simplify it. Is it clear? Or like this also you can do. Next question says 5 cards. There is a 10, a jack, a queen, a king and an ace, and all are of diamonds. Okay? All are of diamonds. They are well shuffled with their face downwards. One card is picked up at random. Now see, there are 5 distinct cards. One is a 10 of diamonds. then another is a king of diamonds, then ace of diamonds, jack of diamonds and queen of diamonds. So these are 5 distinct cards. I am picking up one card. So I have my possible outcomes can be 5 possible outcomes. Either I can pick up, when I pick up the card and I see either it can be ace of diamonds or it can be king of diamonds or queen of diamonds or jack of diamonds or tens of diamonds. So there are 5 possible outcomes associated with this random experiment of picking up a card from these 5 distinct cards whose face is downwards. So total number of elementary events, total number of elementary events is 5. Clear? One card is picked up. What is the probability that the card is a queen? Now out of these 5 cards, there is tens of diamonds, ace of diamonds, king of diamonds, queen of diamonds and jack of diamonds. There is only one outcome which is favorable to my event of getting a queen card of diamonds. Only one is favorable because only one card is the queen card. So M is 1, N is 5. So probability of A is 1 by 5. Now say you have 5 cards. This is first card, second card, third card, fourth card and fifth card. This is say queen of diamonds, jack of diamonds, king of diamonds, ace of diamonds and tens of diamonds. Cool? Next point says that if the queen is drawn and put aside, what is the probability that the second card picked up is an ace? Now see, if you pick up this queen and you put it aside, that means it is removed from this collection. Now you are going back to the collection. If you are now going back to the collection to withdraw one card, now the possible outcomes have been reduced from 5 to 4 because withdrawing a queen is not my outcome. I have already taken out queen and kept it aside. So now I am not left with any queen. So therefore, the possibility of queen coming as my outcome when I pick the card is lost. Now I am only left with 4 possible outcomes. When I go and pick a card, once I have withdrawn the queen card and kept it aside, it can either be jack of diamonds or ace of diamonds or king of diamonds or tens of diamonds. So I have only 4 possible outcomes left. So in this case, this is say first one, and in the second case, total number of elementary events after withdrawing the queen, after withdrawing the queen card is 4. So my new number of elementary events is 4. And what is the probability that now when you withdraw the card, it is an ace card. Now ace card is only 1, so out of these 4, only 1 is favorable to my event, that is of picking up an ace card. So if I say B is getting an ace card, then out of these 4 possible outcomes, only 1 is in favor of this. So I get M is 1, N is 4, therefore probability of B is 1 by 4. It is also saying when you have these 4 cards at your disposal, what is the probability that when you go and withdraw one card, it is a queen card? If I say that my event C is, getting a queen card, try to understand this. Now I have 4 cards left. One is king of diamonds, then jack of diamonds, ace of diamonds and tens of diamonds, right? These are the 4 cards at my disposal. I have to pick one card. I have 4 possible outcomes. Total number of elementary events in this case is 4 because queen has already been withdrawn and kept aside. Now with these 4 cards, what is the probability that you will be getting a queen? Is there even queen present in this 4 cards? No, there is absolutely no outcome which is favorable to event C because there is no queen card in the left out 4 cards. Queen has already been withdrawn and kept aside. That means here M is 0 and N is 4. Therefore, probability of C is 0 upon 4, which is 0. There is no chance that queen card can be withdrawn. There is no chance because the 4 cards that you have do not contain queen card. So there is no chance that you can get a queen card. It is an impossible event and therefore it has probability 0. Clear? Next question says, a carton consists of 100 shirts. So there is a carton which consists of 100 shirts, okay. 88 are good, 8 have minor defects, 4 have major defects. Jimmy is a trader, he will only accept the shirts which are good, and Sujata, another trader, will only reject the shirts which have major defects. Apart from major defects, she will accept all the shirts. One shirt is drawn at random from the carton. What is the probability that it is acceptable to Jimmy and it is acceptable to Sujata? So total number of elementary events over here is what? Total number of possible outcomes are what? 100, because 100 shirts are there and any shirt can be withdrawn when you go to the box and withdraw one shirt, right? So there are 100 possibilities that I have as coming up as the very shirt that I withdraw. So when I put my hand in this box of 100 shirts and I withdraw a shirt, any of the 100 shirts can come up. So I have 100 possible outcomes. 88 are good shirts, 8 have minor defects, 4 have major defects. So 88 shirts are good, 8 shirts have minor defects, and then you have 4 shirts which have major defects. This total is 100. Event A is that the shirt withdrawn is acceptable to Jimmy. Shirt is acceptable to Jimmy. Now see, Jimmy is only going to accept the shirt which are good. So if this event is shirt is acceptable to Jimmy, that means shirt withdrawn is good. Only then can it be acceptable to Jimmy, right? So these are the same events. Shirt withdrawn is good. Out of the 100 shirts which can be withdrawn, how many are possible outcomes which are favorable to event A? That means how many shirts can you say withdrawn are good? Out of these 100, only 88 are good shirts. So out of my 100 possible outcomes, 88 possible outcomes are there which are favorable to event A. If a shirt with minor defect is withdrawn, that is not favorable to event A. If a shirt with major defect, out of these 4 shirts, some shirt is withdrawn, then that outcome is not favorable to event A. But out of the left out 88 good shirts, any shirt is withdrawn, then that is going to be favorable to event A. So I have 88 is favorable to event A and N is over 100. So probability of A is 88 upon 100. Next it says that it is acceptable to Sujata. Now here you cannot do this. What you cannot do? Let me tell you. Shirt is acceptable to Sujata. If the shirt is good, Jimmy is accepting it, and if the shirt is good and has minor defects also, then Sujata is accepting it. She is only rejecting when the shirt has major defects. So it is not like, please mind this, I will not say shirt is acceptable to Sujata means shirt is rejected by Jimmy. I cannot say that. If the shirt is rejected by Jimmy, then it will be accepted by Sujata. It's not like that, and therefore I cannot write B as A bar and calculate probability of B as probability of A bar, which is 1 minus probability of A, which is 1 minus 88 upon 100. No. Because it can happen that Jimmy is rejecting a shirt with minor defects because he is only accepting shirts which are good. So he will reject the shirt with minor defects, and that shirt with minor defects will be accepted by Sujata. Are you understanding? Will be accepted by Sujata because she is only rejecting shirts which have major defects. And then there are shirts with major defects which both of them are rejecting. So I cannot say that shirt is accepted to Sujata only when it is rejected by Jimmy, because Jimmy is rejecting the shirts with major defects which Sujata is also rejecting. So in this case I cannot write B as A bar. Sujata accepting a shirt is not negation of Jimmy accepting a shirt. Is it clear? So What is the probability that the shirt withdrawn is acceptable to Sujata? This is same as saying that shirt withdrawn is good or has minor defects. If the shirt withdrawn is good or has minor defects, then Sujata will accept it, and Sujata will accept only when the shirt is either having minor defects or it is good. Now out of these 100 shirts, if 4 shirts which belong to this category are withdrawn, then they are not favorable to event B, right? Because they are neither good nor they have minor defects, they have major defects. But apart from these 4 shirts, if any shirt from this category is withdrawn, then all those outcomes are going to be favorable to event B. So how many total number of favorable outcomes are there? 88 plus 8 is the number of favorable outcomes to event B, which is 96, right? And now n already is 100, so probability of B is 96 upon 100. Is it clear? Once you have done this, let's move to the next question. 2 dice are there, there is 1 blue die, 1 grey die, they are thrown at the same time. Write down all the possible outcomes. First of all, let's write all the possible outcomes. When you have 2 dice, each die has numbers from 1 to 6 written upon it, second die has numbers from 1 to 6 written upon it. When both the dice fall on the floor, there is a number which comes on the first die, there is a number which comes on the second die. So 2 numbers or a pair of numbers is what we get as the outcome each time we roll a pair of dice. So the experiment that we have is rolling a pair of dice, right? So I will get a pair of numbers as the output. Both numbers individually will be ranging from 1 to 6 because that is what a dice has. So either you can have 1 on the first die, 1 on the second die. I am just writing like this. 1 on the first die, 2 on the second die, 1 on the first die, 3 on the second die, 1 on the first die, 4 on the second die, 1 on the first die, 5 on the second die, 1 on the first die, 6 on the second die. 1, 7 cannot exist, that means 1 on the first die, 7 on the second die. No, because a die can have numbers only from 1 to 6. Or you can have 2 on the first die, 1 on the second die, 2 on the first die, 2 on the second die, 2 on the first die, 3 on the second die, 2 on the first, 4 on the second, 2 on the first, 5 on the second, 2 on the first, 6 on the second. Or you can have 3 on the first, 1 on the second, 3 on the first, 2 on the second, 3 on the first, 3 on the second, 3 on the first, 4 on the second, 3 on the first, 5 on the second, 3 on the first, 6 on the second. Is it clear? Or you can have this 4 on the first and rest on the second. Right? 5 on the first, 1 on the second, this also they can have. 5 on the first, 3 on the second, 5 on the first, 4 on the second, or this, or this. Or you can have 6 on the first, 1 on the second, 6 on the first, 2 on the second, 6 on the first, 3 on the second, 6 on the first, 4 on the second, 6 on the first, 5 on the second, 6 on the first, 6 on the second, that is it. These are all the possible outcomes associated with the random experiment of rolling a pair of dice. When you roll a pair of dice, any one of these outcomes come up. So I am representing the outcome of getting 1 on the first die, 1 on the second die like this, as a pair 1, 1. I am representing the outcome of 4 on the first die, 3 on the second as 4, 3 within braces. So this is the representation of my elementary events, so that the moment I look at the representation, I am able to understand what it is standing for. Like 5, 3 within the braces is standing for the possible outcome that 5 is coming on the first die, 3 on the second, or you can say 5 is coming on the blue die and 3 is coming on the grey die. So let's fix that the first numbers in each pair that you are getting are the outcomes on the blue die, and the second numbers that you can see in each pair are outcomes on the grey die. Clear? So there are 36 possible outcomes. You can count. This is 36 total, 36 elementary events are there, which are my possible outcomes associated with this experiment. What is the probability that the sum of the two numbers appearing on the top of the dice is 8? out of these 36 possible outcomes, which are the outcomes which are in favor of event A, that the sum is 8. That the sum is 8. How many are in favor of it? Now clearly, if you can see, this is one outcome which is in favor of event A. Because if this comes as the outcome, then the sum of the two numbers on the two dice is 8. Moreover, this is also in favor of event A. 3 plus 5 is 8. This outcome is also in favor of event A. This outcome is also in favor of event A, and this outcome is also in favor of event A. So out of 36 possible outcomes, there are 5 possible outcomes which are in favor of event A, because they are the outcomes in which the two numbers that you get on both the die is adding up to give you 8. So your M is what? Let's just check. Here this is 8, then this is 8. After this is 8, and then this is 8. So your 1, 2, 3, 4, 5. 5 and N is 36 total possible outcomes. So probability of A is 5 by 36. B is that the sum is 13. What is B? B is that the sum is 13. Out of all these possible outcomes, how many are there which are in favor of event B, that the sum is 13? Now clearly see, in the first row, maximum sum is given by 1, 6, it is 7. Let's move downwards. Here maximum is given by 2, 6, this is 8. Here the maximum sum is given by 6 plus 3, which is 9, okay. Here maximum is given by 6 plus 4, that is 10. Then maximum is given by 5 plus 6, which is 11. And then in the last row, maximum is given by 6 plus 6, which is 12. That means the maximum sum that you get when you add the two digits that you're getting on both the die is 12, and minimum you can get is 2. Minimum sum you can get is 2, maximum you can get is 12. There is no outcome which is going to give you two numbers on the two dice, which on adding up is going to give you 13. So right now, no outcome is favorable to this event. There is no outcome, out of all the outcomes, there is absolutely no outcome which is supporting the statement of event B, that the two numbers that you're going to get up on both the dice are going to add up to give you 13. No, there is no such outcome. And N is 36. So probability of B is 0 upon 36, which is 0. That means this is an impossible event. Never ever will you get any outcome which is going to be such that when you add the digits on both the die, you will get 13. This is an impossible event to occur. C event is that the number is less than equal to 12. The sum is less than equal to 12. Now you can see when you add the two digits in the first row, you're getting 2, 3, 4, 5, 6, 7. So from 2 to 7 is the sum which is less than equal to 12. So all these are favorable outcomes to event C. This sum is 3, sum is 4, sum is 5, sum is 6, sum is 7, sum is 8. All these are less than equal to 12. So even these are my favorable outcomes to event C. Sum is 4, sum is 5, sum is 6, sum is 7, sum is 8, sum is 9. Again, less than equal to 12 in each case. So these are also favorable to event C. Sum is 5, 6, 7, 8, 9 and 10. All these are less than equal to 12. So all these are favorable. Then sum is 6, 7, 8, 9, 10, 11. Again, all the sums are less than equal to 12. So all these are my favorable outcomes to event C. Sum is 7, sum is 8, sum is 9, sum is 10, sum is 11, sum is 12. Again, the sum is less than or equal to 12. And so all these are also favorable to event C, because the sum of the two digits that comes up on both the dice in any of these cases is always going to be less than equal to 12, because I told you minimum sum is 2, maximum sum is 12. So the sum is going to lie between 1 and 12. The sum is going to be less than equal to 12 always. So my M is 36, because all the outcomes are favorable to event C, and N is also 36. So you will have probability of event C is M upon N, which is 36 upon 36, which is 1. This is a sure event. This is a certain event. This event will always occur in any trial of this experiment. That means you roll this pair of die any number of times. Each time this event will definitely occur. Each time whatever output you get is definitely going to be such that when you add the two numbers on both the die, the sum is going to be less than equal to 12. Every time this will happen, because you can see each time that you roll this pair of dice, you will get one of these outcomes, and any of these outcomes is favorable to event C. So one of these outcomes is going to occur, and when the outcomes occur which are favorable to an event, you say that event is going to occur. So any number of times you roll this pair of dice, each time you will be getting one of these outcomes, and all these outcomes are supporting the statement of event C. That means event C will be occurring in every trial. So it is a sure event, certain event, its probability is 1. Is it clear? Revise the questions nicely. That's it from my side. Thank you.